Hi guys, and welcome to our multiplayer game development workshop with full stack JavaScript. We'll be using Node.js, Socket.io, and of course some browser-side features like Canvas to build a real-time multiplayer game. And the game itself will be quite simple, however, it will show the main concepts of building online multiplayer games, and it will act as the beginning, as the first step in designing your own game, I hope, right? The idea for this workshop came from the Node.js Global Summit, where I was presenting this very project in the online Node.js conference, and there were more than 1,000 attendees watching it online, so there was clearly some interest towards building games in JavaScript, so I decided to make it as a YouTube workshop as a full complete video. And just a couple more words about the format of this video. My typical videos on this channel are tutorials, so I'm trying to keep them short, around 7 or 10 minutes maximum, and if there is a longer concept, more complex concept to explain, I'm trying to break it down into the smaller tutorials that are independent. And this video is totally different, so we'll take this project from the beginning, from the scratch. I assume no prior knowledge of Socket.io or Canvas or game development, and we'll build it until the game is complete. So I assume it will take around 1 hour, maybe a little bit more, maybe a bit less, but this will be an end-to-end workshop that will give you the complete project at the end. So let me know in the comments, what do you think about this video format? Should I continue that? Should I record something similar for the other projects? Or should I stick to my good old 10 minutes long tutorials, right? So let's talk about the game now, right? So what exactly are we building here? And the game is super simple, as I said. Unfortunately, in 1 hour, I cannot build a AAA game, but it will show you the main interesting concepts of game development. And this is a variation of 5 in a row. So in order to win, a player needs to build a row of 5 cells, and here this player just built the row of 5 cells, and that player receives "you win" message, right? And if someone else does it, then they can win. But unlike with the normal 5 in a row, where players are making turns and there is just 2 players playing, this game can be played by multiple players, more than 2, 3, 5, 10, you name it. And players can override the values of the other players. So this guy can place their tokens on top of the other guy's tokens, right? And in this scenario, you need to figure out how to place your tokens, on one hand building some sort of an offensive line, but on the other hand making sure that you do not let the other player win. So to be honest, I haven't play tested this game. It may be fun to play, it may be not that much fun to play, but this game contains everything that you need to start with online game development. It contains the notion of a game world and the level, which is our board. And this level has a state. So if new player joins, I'll just reload the page to simulate a new player. They receive the state of the game as it is, and they can continue playing together with the other players. Quite obviously, this is a real-time game, so the turns are appearing as they are made, and also this game has certain rules, certain game mechanics that we are checking. So for example, we want to restrict the frequency at which the player clicks the board, so that you don't just go and madly click around the board trying to place as many tokens as possible, but rather you are only allowed to do that once per couple of seconds. That's what we will do. And of course there are the win conditions, right? So once there is the line, there is the new round that starts, the board is cleared, and the players continue to play the game. Once you master this project, you can go on and introduce more complex concepts. For example, you can introduce graphics with sprites and animations, or even 3D graphics with WebGL, or build a more advanced game mechanics like a shooter game or a strategy game, but it all starts with simple games like this. All right, so let me collapse this Windows and let's go and check out the code. So I took a little bit of freedom and I decided not to start from nothing, from zero. I decided to start with a little bit of skeleton, a little bit of code, just because it is not fun to show how I am writing HTML on the screen. I'm pretty sure that all of you guys are capable of writing a simple HTML like this one. So we'll start with this interface that does nothing at all at this point. And on the client side, we have index.html file, we have some CSS that is completely out of the scope of this workshop. It just makes this form looks a little bit nicer than by default. And also there is an index.js file that has a couple of functions, right? So first of all, there is a simple event handler on this form that says say, and if you type something and hit enter, this event will be caught by the function onChatSubmitted. And all this function does, it really just takes the text out of the form and puts this text on the top of the form on this unordered list, right? Right here. So there is no network interaction whatsoever. We're just taking the text from here and putting it over there. Right, so this is our basic client structure. Now on the server side, I am starting from the scratch, and on the server, all I have is server.js file that has nothing except server will be here, console log, it's my hello world server, but also on the server side, I added into the package JSON, I added one dependency that is called nodemon. So what it allows me to do is to start the server in the console, and whenever I'm changing something, nodemon will automatically reload and relaunch the server. So this way I can just keep updating the server and it will be updated on the background by nodemon. So let me just show you how it works. If you haven't worked with nodemon before, let me try to arrange this window so that you see both of them. Something like this. And here I'll type hello world. And the moment I'm saving the file, you see what happened. In the console, nodemon picked up that there is a change in one of the files and it restarted the server, hence the hello world text appeared in my console, right? So this way you will know that I'm not reloading the server explicitly, but it is this console window is there on the background and it will just keep my server up to date. I'm not implementing any hot reload on the client. I'll be just updating it by hand, pressing Command R, refreshing the browser manually, but this is not a big deal at all. All right, so let's go and start writing some code, right? So the first things first, we want our server to do something, like maybe the server needs to be able to serve the static files. I'll start with requiring HTTP. And then, of course, like millions of other projects on internet, we'll be using Express.js in order to organize our server logic. So let's go and do npm install Express. Right, so Express will be there in just a second, and npm run dev. It will run my nodemon script. So now the server is updated again. All right, so let's create our Express app. Let's require Express. And the next thing is to create an app, just like this. Finally, we want this application to do something. So app use, we'll add a middleware to the stack of Express, and we'll say express.static. And this will be serving static files. Where will it be serving the static files from? Well, my project layout is as follows. So I have two folders, server and the client. I like to keep things separate. I don't like to mix them together. So in order to serve static files, we'll need to take one folder level up from the current folder of a server and then go to the client folder. And in order to put that down in the code, we'll use the variable called dir name that is available in Node.js. This is our current folder, current directory. Then we'll go one level up and then we'll go to client, like this. So now my application will be serving static files from this client folder. Now the next thing is to create an HTTP server. Right? HTTP create server. And in order for server to work, we need to pass an event listener. What will server do if there is a new event? And the event listener is the app itself, the Express app. So far, so good. I'm pretty sure that you did it 100 times already, but for the sake of completeness, let's do that once again. So, and the server needs to listen somewhere on the port. Let's make it port 8080. And if everything is successful with listening to 8080, we want to print something to console to say that we are ready. Server is ready. Now, it's also a good idea to add another event listener and listen to the error event. If there is something wrong, for example, the port is busy, or there is another issue starting the server, we want to know about that. So let's capture the error. And if that error happened, we'll say console error and just print it out. So that is our very basic server. So let's try to arrange the IDE and the browser on the same screen. Something like this. And if I did everything correctly, if I navigate to localhost 8080, I should see the same UI as I was just showing you before. All right, perfect. Now I see that the file index.html and the CSS and also a little flag icon that I have created with a little flask right now here, they are all showing up in the browser. And that means that I'm almost done with the boilerplate and I can start writing a more exciting part of the application, the real-time communication part. we will build real-time communication in our game with the help of Socket.io. And if you haven't heard yet about Socket.io, it is a great time to check it out. This is an amazing library that has been there for a while. And the best part about it, right, is that we could, of course, go with something like pure WebSockets, but then we will get quite a low-level protocol. So we would need to handle things like disconnects, like missed messages, etc. and so on by ourselves. We don't want to write that layer, really. What Socket.io gives you is significantly higher level of abstraction when you're writing network applications. So you have the notion of sockets, you have notion of rooms. The clients will reconnect automatically to the server if the connection is lost, etc. and so on. So it is much easier to build a meaningful application with Socket.io than using just pure sockets. So what will we need in order to make Socket.io work? So let's stop the server and let's npm install Socket.io. And Socket.io, obviously, it has two parts. It has client-side part and the server-side part. Right now we're installing server-side part, and you'll see in a second how to get the client-side up and running. Right, so what we'll do here is, well, require Socket.io. And now we will create an object that is called IO, and we will just use the Socket.io function to wrap around our server. And the Socket.io pretty much works like this. It works like a wrapper around the server. It will filter out the requests that are related to Socket.io, to real-time communication, and the rest of the requests it will just pass to the implementation of a server. So it will pass it to our Express application. So in this way, you can have both Socket.io real-time application running on the server and also your classical REST APIs defined in Express.js. This is quite convenient. So in order to implement some logic with Socket.io, we need to add an event listener. So what will we do when there is a new connection? This is the main event in Socket.io. That's when the new client is connected, and there is a separate object that is called sock, short from socket, that represents the connection to this specific client. So each time somebody connects, one browser tab is connecting, you open a new browser and you connect, you get a new invocation of this event listener, of this function, and this function gets a new object that is sock. And this object is your way of communicating to this specific browser tab or this specific client. So for now, let's just say console log someone connected. So what about the client side? How we are going to get the client side of a Socket.io? For that, I will go and open our HTML file, and I will add another script tag here. There are multiple ways to connect your client-side script, right? If you're using Webpack or Babel, you can download separately and install separately a module for client-side part of Socket.io. But if you're just using plain HTML and JavaScript, there is a neat trick. Let's add a script tag here and point it to the script that is in socket.io, socket.io.js. So where is that file? If you check out the file system, you will see that there is no such file, and my WebStorm is highlighting it, saying that this file is in fact not found. So where will it come from? And the trick is that this little module here, Socket.io module, that is wrapping around the server, it will intercept the request for Socket.io.js, the client-side part of the Socket.io, and it will respond with the contents of the client-side script. So this way, this module is kind of containing both sides, the client-side part and the server-side part, right? So it's so easy to add the client side of the Socket.io to your client. So now let's go to our JavaScript file, and here I'll just remove my welcome, and here I'll say sock equals IO. And this should establish the connection to the server. And if I did everything correctly in my console, I should see that someone is connected. So let me just rerun the server again, and let's go to the browser. And I'll refresh the page, and you see someone connected. That means that Socket.io connection has been successfully established, and now I have a real-time communication between the client and the server. But of course, just establishing the real-time communication is not interesting enough. It will be more interesting to exchange the actual messages, the actions between the client and the server. But now let's try and see if we can build a very simple chat based on this Socket.io mechanics. So the first thing that I want to do is, instead of just writing to the console, I remove that line. What I want to do is to send a new message to the client. So I'll say sock sock.emit, it's like emitting the event. And the first goes the type of the event that you're sending over the network to that specific client. And the type of the event for me will be message. You can think about any type at all. It's not a keyword, not a special word. It can be text, it can be log, chat, or anything else. So message is just a random word that I have picked for the sake of this demonstration. So I'm emitting a message, and the value of that message will be you are connected. So whenever the client is connected, I'm sending to the client a message, you are connected. On the client side, I'll go and I'll listen to that message. So I'll say sock on message. What I want to do if I receive a text, well, I just want to output it in my little unordered list here on the top in my chat window. So what I'll do, I'll just pass it to log. And I'll do it like this. So let's see if that works. Save it, update, and you are connected. I can shorten this record a little bit, and instead of just having this anonymous function, I can pass log as an event listener. This way, any message will be just straight away logged to my chat window. That will also work. So now I have one-way communication. My server can send the messages to the client. Now, what about the clients being able to send the message to the server? And for that, I have a function already on chat submitted that I can use, right? So when I'm submitting the chat, right now I'm not doing anything. I'm just printing the same value on the client side. Instead of doing that, what I want to do is I want to emit the message, and doing it super simple, sock.emit, just like on the server side. The API is exactly the same. I'm emitting the message, and I'm passing the text as the value of this event. Now there is a little problem. This onChat submitted function doesn't have the access to my sock object, right? So I can solve it by just making sock global, which is a big no-no in the modern JavaScript. We don't want to pollute the global scope. So instead, I will wrap my onChat submitted into the other function, and I'll just pass here a sock object. And here, onChat submitted, I'll pass it as well, right? So I'm having a function that creates an event listener, and that external function accepts the socket object that then will be accessible from within the internal function. That should also be quite easy for you guys. Now, I'm able also to send the messages to the server. If I type here, let me refresh it. If I'm typing something here, you will see that messages are not appearing because they are only sent to the server. I'm not doing anything else with those messages. Now, on the server, what I want to do if somebody sends me a message, let's add an event listener, sock on message, right? So what I do if the client has sent me the message? Well, what I want to do is I want to grab the text of that message, and I want to send it to everyone, to every client that is currently connected to the server. And for that, there is a shortcut, io.emit. So, and I'm just sending a message with the given text. Notice here a very important difference. There is a big difference between sock.emit, because sock is your channel to one single connected client, to one single browser tab. So if you're calling sock.emit, you will send a message to one single client. But if you're calling io.emit, that means send it to everyone, including the client that has sent the original message. So this is a broadcast to everyone, including the client themselves. Right, so now, if I did everything correctly, the client will send the message to the server, and server will reply back with the same message, and that's when the client will print the message on the screen. So, hello, I will say to the server, and I'm getting hello back. Now, if I have a second client somewhere, so let me open a second client, I will receive a very basic chat functionality. Let's align those windows, and let's say here, hi, wanna play? And that message appeared for all the other connected clients. I'm demonstrating it with just 2 connected clients, but if there are 3 or 4 or 10 connected clients, they will all be able to exchange the messages through the server. So once the message reaches the server, it will be sent back to everyone else, right? So this one is simple. And now we are on a very important milestone of a multiplayer game development, because chat is like a hello world for the multiplayer games. If you are able to exchange messages in real time, you will also be able to exchange game turns in real time. And the next question is, how do you organize those game turns? How do you add the board and the graphics to your game? And this is exactly what we'll do next. But since this is such an important milestone, what I want to do is to just add a commit. So you will be able to check your code against this state. If anything is not quite right for you, you will be able to figure out what exactly is the difference between your code and my code, or you can just use it as the basic structure for the real-time application and start building your own app from this place, right? So commit it and let's restart the server. So our next step is to add some graphics to our game, and in order to do that we will add a canvas element, one of the most powerful HTML elements ever created. So I'll create a canvas element with height of 400 and width of 400. You may be thinking, why are you doing this? Don't we have CSS to define heights and width? Why are we doing that in HTML? And the thing is that here height and width is not exactly the dimensions in pixels of the canvas element. These sizes will have an impact on the resulting size of the element. However, it's not a direct impact. That will depend on the pixel density of the screen that we're working with, right? It can be 400 by 400, or it can be something like 800 by 800 easily. This height and width will define the internal coordinate system of a canvas. So top left corner of a canvas will have coordinates 0, 0, and bottom right corner will have coordinates 400, 400. All right, so we have canvas. Now let's use it somewhere. So first thing to do if we want to do something with canvas is to get the canvas object itself. So I'll find it on the document. I'll use query selector because I just have one canvas and I can query it by canvas. So that will give me first best canvas. Since I just have one canvas, it will work. And once you have the reference to the canvas element, it's not yet enough to start drawing on that canvas, start rendering something. What you need to do is to create a graphical context on that canvas. And doing that is also very easy. So const ctx is commonly referred as context, and we'll call the method on the canvas called getContext. And we'll pass the name of the context, which is 2D. So we're working with a 2D context. That's not the only context that Canvas supports. So for example, you may want to start working with WebGL, and that will be a different context that will allow you to use 3D scenes. In this tutorial, we will be working with a simple 2D graphics, and that's why we're taking 2D context. Now that you have a context, you can start drawing anything at all in the canvas. By the way, let's refresh the page and see that the canvas really appeared on the page, right? So this blank space here is canvas, and you can draw anything on it. For example, you can fill a rectangle. So ctx fill rect. So we're passing the coordinates. Let's say the top left corner of this rectangle will be in the coordinates 50, 50, and the width and height of the rectangle will be 20 by 20 pixels, something like this. And if we refresh the page, surely enough, we have our square rendered on the canvas. If you want to render something over the whole canvas, the beginning coordinates are 0, 0, and since in HTML we set it to 400, 400, that will be the width and height of canvas. So this way you can render the rectangle over the whole canvas. And if you don't like black color, you can use ctx fill style and pass here any valid CSS color. So you can pass color code, or you can pass the name of the color. So coral is the one of these possible CSS color names, and here you see that our rectangle became, well, it became reddish orange, whatever coral stands for. All right, so now you get the idea, you get the context, and then you execute the methods, the functions on this context in order to draw anything. So you can imagine if you will start extracting the functions that are drawing certain parts of your game world, every function that draws anything will require the access to context. And there are two ways to deal with it. The first way is to pass this object context to each and every function that will have to draw anything. But then this context parameter will be all over the place. It will be quite inconvenient to use this kind of graphical API. What I rather want to do is to have a set of functions that are already working with a given context. And to do that, I'll create a closure. And I'll call it getBoard, right? So I want to create a set of functions that we will be using to render a game board. That's why I will call it getBoard. And in that getBoard function, I'll pass the canvas that I want to work with. And inside of that function, I'll get the context. ctx equals canvas, getContext, and 2D. Now, inside of this function, I can start creating other functions that will all have the access to the context. For example, I can create a function called fill rect. And that will be a function that accepts only x, y, and color. Let me write it here, x, y, and color. And it will do ctx fill style equals color. So as you see, this fillRect function already has the access to ctx from its external scope, so I do not have to pass it explicitly to this function. And let me just fill the rectangle. X, Y, let's put it 20, 20. So this function will allow me to render small squares on the screen in X and Y coordinates. And of course, I need to return this function from my outer, from my closure function, from getBoard, fillRect. How will I use this function now? Well, it will be very, very easy. So I will say that I want a fillRect function created with the given context, with the given canvas. And now, whenever I need to render a rectangle, I can just do so. fillRect 50-50 of color green, and that will give me a rectangle without ever passing context again. So this is a nice little technique that many JavaScript libraries use, and it's not specific to game development at all. This is general programming technique, right? So we're creating the function, passing everything that we'll need to share with inner functions, and then we're returning a set of inner functions from that external function. And what's even better is once you start organizing your application in a set of modules, once you start adding things like Webpack, this block, this function here, is a separate module, and it encapsulates all the details about rendering of the game board, including the context itself. So if at some point you will decide, hey, I want to render my board in 3D with WebGL, you will only have to change the implementation of getBoard, but all the other functions within your application will not know anything about this change and will continue working just like they were. So this is a nice little abstraction layer over the graphical details of your game. So now that we have this basic drawing capabilities, we can start extending our game and we can start adding some interaction, because games are all about interaction. It's about making turns and receiving the turns of the opponent. And to have the interaction, let's add a click listener to the canvas. And what I want to do when I click the canvas, I'll just render a rectangle in that place on the canvas. So click and render the rectangle. That's my first goal. So the first thing that I will need to do is I will need to add an event listener to the canvas. Let's create a function onClick. And this function will receive an event as usual. And now let's register this onClick function as an event listener on the canvas. So canvas, add event listener, onClick event, and our function onClick. So what do we want to do within that function? We need to figure out what is the coordinates of the click within the canvas and render the rectangle there. So we already have a function to render a rectangle, fillRect. Now we need to figure out the coordinates. And to do that, I'll create a separate function. I want to have it separately from the onClick function, because it's kind of a reusable piece of code, and get canvas coordinates or get click coordinates. That's how I will call it. So this function will receive the canvas, and actually it will receive any element at all. It's not really specific to the canvas or to game dev, and the event that has occurred, and it will return X and Y coordinates of the click. Now, how exactly do we calculate those coordinates? If you go and browse MDN documentation, for example, you will soon find out that there is no clear way to find the coordinates of a click within the element itself. However, it is very easy to find the coordinates of a mouse click relative to the current content area, to the current client. You use client X and client Y for that. Now, it's also quite easy to find the coordinates of the element itself, the coordinates of the canvas within the same coordinate space. And if you combine those two sets of the coordinates, well, you will get the relative coordinates according to the canvas coordinate system. The first thing is to get the top and left coordinates of the bounding client rect of our element. So doing that is easy. Element get bounding client rect. And then we need to get client X and client Y coordinates of the event object. Now, once we have all these values, it is very easy to get the x and y coordinates of a mouse event within the canvas. And the result will be, this coordinates that we're looking for will be, the value of x will be client x minus left, and the coordinate y will be client y minus top. Now we have a very useful function, getClickCoordinates, that hopefully will work. We'll see that in a second. And on click, we can get x and y from getClickCoordinates. We're passing the canvas as the element that we want to get the coordinates relative to, and the event that we just received. Now we have the x and y of a click. Why don't we render a rectangle right there in x, y coordinates, x and y. And let's keep it green for a second. All right, so let's see that all works. And as you see, as I started to click, the little green squares are indeed appearing on the screen. One little thing that I do not quite like is that my little squares are not appeared in the middle of the click, rather the top left corner of the square appears in the click position, but that is due to the fact how exactly the rectangle is rendered, right? So if we go and check out this getBoard function and fill rect, let's say that we want to render it right in the middle so that the center of a rectangle is in x and y coordinates. We can do that x minus 10, y minus 10, 20, 20, and that will give us rectangles in the middle in the click position itself. Perfect. Now we have a little bit of interaction between the player and the game. So let's say that those clicks on the canvas are indeed the turns, and we want to share that turns with the other player. How would you do that? And doing so is no different from sharing chat messages. That's why I was saying chats are the hello world of multiplayer game dev. Once you know how to build the chat, you can start exchanging the turns. So let's do that. Let's say that our clicks are our turns and we want to share those turns with the other players. What will we do? So just like with the chat, instead of filling the rectangle immediately, we want to send a message to our server. And to do that, we'll say sock emit. And this event type will be called turn to distinguish between the text and the turn. And I'll send just the coordinates, x and y coordinates, exactly what I have received from the getClickCoordinates function. Now our game client will be sending turns to the server, however it is not yet reacting to the turns coming from the server, so let's fix that. Sock on turn. What will we do if we receive the turn? Well, we'll get the values of that turn, x, y, and we'll use these values to fill rectangle with x and y. By the way, if I do not set the color, it will be black by default, so this will not break even though I'm not passing the color explicitly. Now on the client side, I am sending the turns and I'm ready to receive the turns from the server. However, if you refresh and try to click around, you will see that nothing happens, and that's because server doesn't know anything about those turns. Server is just ignoring those kind of events. So what we have to do is to add another event listener on the server, and we'll listen to the turn event. And what we'll do here is we'll take x and y coordinates from the turn and we will send it back to every other connected client, just like with the chat. IO emit, turn, and x and y. That will be our code for sharing the turns between the clients. Now let's refresh this page once again, and once we start clicking, you see the turns are appearing again, but now the big difference is that they are coming all the way from the server back to the client. And now if you see this rectangle appearing on the screen, it means that the server knows about those turns as well. And that's where you can start building the game mechanics. So let me just show you how it will look with several connected clients. So let's add a couple more windows. Now, whenever one of the clients is clicking on the screen, the others will see those turns and will render those turns on their own screens, right? And we have already created a very basic useful application. You can start using it, for example, to build some kind of interactive drawing tool, right? So you see, as I'm starting to click, the same picture appears on everyone else's screen, right? Obviously, that's not what we are planning to do here. We plan to build the game, and to build the game, the next thing that we need to do is to distinguish between the players to see who exactly made that click, because right now they're all the same color, they all seem like the same turn from the same player, and that's not how games work. But before we do that, let's go back to the console and let's do git commit and save our development progress. As usual, if you're following along and you want to check your code against the code that I'm writing, feel free to check it out on GitHub. I'll leave the links in the description for this video, or feel free to start building your own game from this point on. All right, now we're ready to start identifying the players. So how exactly will we identify the players? Of course, we could go on and build some sort of authentication and logging in system and have some kind of user identity associated with each player, but that would be a project in itself, and in this case we would not be able to finish this project within 1 or even 2 hours, right? So I am suggesting a much simpler solution. Each time when the new player is connected, right? Here we have the sock, his identity. We will assign a random color to that player, and that color will identify that player against the others. There are a few ways to generate a random color, and it is quite easy to write that code manually, but why would you do that if there is already a Node.js module to do that? In reality, the totally random color can be white, for example, that will not be visible at all, or it can be very acidic, very unpleasant to look at. So there is this module that is called random color, and I'll install it right now. npm install random color that claims to generate a slightly more pleasant colors, and we'll be able to check that right now. And by the way, let's run the server so it is updated on the background, and we should be able now to use that module to generate the random colors. Random color, let's require the module, and whenever the player is connected, let's create a color associated with that player's token, random color, and that will be it. Now for each and every connection, server assigns its own color, and all we have to do now is to pass that color to all the other players. Color. And of course, since we're sending it from the server, the client also needs to be aware of the color, and it will receive the color, and it will pass it to the fill_rect function, like this color. So let's save client side, let's refresh our browsers and see how it works, right? So the server assigned this purple-blue color, not very good at identifying colors, to be honest. And you see now each connection, each player has its own color assigned to them, right? So now you can distinguish clearly who clicked where and whose turn was that. Of course, if you plan to make it a real actual game, you need to make sure that those colors do not clash, because the clash probability here is quite high, and you may end up with having a couple of players having exactly the same color, and the server will think that they are indeed the same player, as you will see later. Enforcing uniqueness here is not a very difficult exercise. Alright, so let's move to the next phase. Right now, players are clicking wherever they want. But we want to have a little bit more structured game board. So there is a grid, and player can only click on the cell within the grid, and that is their turn, like in chess or checkers and all those kind of board games, right? So how do we approach that? How do we draw grid on the client side? And let's add another function here that will be called draw grid. So I will not pass anything to that function. We'll talk about the parameters later. And of course, let's not forget to export draw grid. Sorry, to return draw grid from our getBoard function. And let's right away start using that function in our code. Don't forget to destructure this function from the result of getBoard, draw grid. And then we can start using it. So this function does nothing for now. So how do we draw a grid? Well, it is quite simple. The grid is made of lines. So if we figure out how to draw a line, we can then draw a grid. However, drawing the line is a little bit of a tricky process when it comes to this 2D API, right? So in order to draw the line, we need to create a path, and then we need to stroke that path. How will that look in the code? We need to call first cdx begin path. Now the path has started. Now we need to move our virtual pen with move to some coordinates, let's say 70, 30. And then we need to create a line to some other coordinates, let's say 200, 300. But at this point, line is not yet visible. So if we save this function and refresh, you see there is nothing on the canvas, right? So in order to make this line visible, we need to call cdx stroke. And just like with fill, stroke will apply stroke style in order to draw the line. So as you see, once I have added the stroke, the line appeared on the screen. Now we know how to draw a line, and this is a good start. Let's figure out how to draw several vertical lines in the way that it looks like a game grid. And to do that, we can create a simple for loop, and notice where I'm placing it. I'm placing it after begin path because all the lines will belong to the same path and we will stroke them in one go. So I'm creating a loop here for let I from 0, let's say we want 10 lines. We'll figure out the exact number in just a second. I++. For each iteration, I want to draw a line, but instead of moving to the same place, I want the coordinates to change with every iteration of the loop. So let's say I multiplied by 30. And starting from 0, this is a vertical line, so this is the top of the vertical line. My x coordinates are moving from the left to the right. Line 2, again, I multiplied by 30. The x coordinate is exactly the same, but the y coordinate is the end of the grid, the end of canvas. So let's see how that works. And now instead of one line, we have 10 lines that start to look like a game board a little bit, right? It will be much better to have this size calculated instead of hard-coded so that we can work with the canvases of different sizes, right? So in order to do that, I will go here on this level, on the getBoard function, and I will add another parameter, which will be num cells. This will be how many cells do I want to fit in that canvas. And by default, I'll just pass 20 to have something to work with. So now I know the size of the canvas, and also I know how many cells do I want to fit. And from these two numbers, I can easily figure out what will be the optimal size of the cell. So cell size will be equal to canvas width. I'm assuming that the canvas is square, so width and height are the same. If the canvas is not square, you need to take the minimal of width and height. So I'm taking the width and I'm dividing it by the number of cells to get the size of one cell. And this value can be not an integer value, that can have fractional values inside. And since this is pixels, I want to have this value in pixels. I do not need those fractional numbers, so I'll just do mass.floor to round it down, and I'll take the biggest integer number to fit the number of cells, right? And now, instead of having I running from 0 to 10, we're running it from 0 to num cells plus 1. And instead of using the fixed value 30, we're using the cell size here and here. And also here, instead of using the height of the canvas explicitly, we can do better. We can say cell size multiplied by number of cells. So let's refresh this page and see how it changes. Right now, you see the board is starting to shape up. We have all the vertical lines rendered. Now we can just add the horizontal lines to those. And in order to make horizontal lines, if you have vertical ones, you just replace x with y's and y's with x's, and it will work. So like this. Let's see. And voila, I have the game board rendered on the screen. The only thing that it's a little bit too high contrast. I'm not sure how it will look like on video, but right now when I'm looking at the screen, it's a little bit too black. So I want to decrease the blackness of this grid. So I'll go here and say CDX stroke style, just like fill style, but for strokes. And I'll put it something like 333. So it's going to be black, but not that black. It's going to be dark gray. So now it's much easier to look at these colors. So now we have the grid, and we can still click anywhere on the screen. It is not really aligned on the grid or anything, so that will be our next step. But before we continue, I want to add a couple more useful functions. The first function will be called clear, and it will be clearing the canvas. I need to restart the round. I want to get rid of everything that was rendered on the canvas before and start from the scratch. Clearing things in canvas is super easy. CTX clear rect, and we need to pass the coordinates. If I want to clear everything, that's going to be 0, 0, canvas width, canvas height. Perfect. And I'll create one more function called reset. And that function will be just drawing the initial state of the board. So I'll call clear, and then I'll call draw grid in that reset function. Now I do not want to expose draw grid directly. Instead, I will just expose a function called reset. And let me update this code a little bit. And now when I'm starting a round, I will just reset the board instead of telling explicitly I want to draw a grid. So why am I doing that? Seemingly my code became slightly more difficult, slightly more complex. And the reason is that in this game, we only need to draw the grid in order to reset it, right? And in some other games, there may be some other UI elements that you want to draw. And this function will be just a wrapper that sets everything to the beginning, sets everything to the initial state. And what is exactly inside of that initial state, the other code should not care. So our code just calls reset, it doesn't know what's happening underneath inside of that reset function. Now the next logical bit would be to align the turns with the grid that we have just created. Right now you can click anywhere, it is not really aligned, and we want to figure out what is the exact cell that we clicked and put the rectangle exactly in this cell and not elsewhere on the board. Here I will start from a small refactoring. Instead of function fill rect, I will call it fill cell, and I will change the implementation. Now X and Y will not refer to the coordinates of the click or the coordinates of the canvas, it will refer to the cell coordinates. So this cell, for example, will have coordinates 1, 1, and this cell will have coordinates 2, 1, etc. and so on. So here the change will be very small. All we need to do is fill the rectangle starting from the cell size, X multiplied by cell size, Y multiplied by cell size, and cell size will be the width and the height of the rectangle. So I will update the function name here and update the function name here as well. And let's just give it a try. So now if I write somewhere fill cell 3, 2, it should fill the cell perfectly aligned to the grid, and you see that just happened. So now I have a new function that works with the grid rather than with the whole canvas. It is restricted to the cells of the grid. Now the next step is, instead of sending the click coordinates to the server, we need to send the coordinates of the cell that has been clicked. And in order to do that, we need to figure out what that cell was. So we'll need another function for that. And I'll call this function get cell coordinates, right? Why am I putting this function into the same block of function as the rendering functions, right? Because this function is not rendering anything. Well, the reason is that this function is transforming from the screen coordinates to the world coordinates. And in order to do that, it needs to know the details of how exactly the world is rendered. So for example, in our case, it needs to know what is the size of the cell to tell which cell was clicked. So this function will accept X and Y coordinates of the canvas, and it will return X and Y coordinates of the cell. And getting that coordinates is very easy. So we'll do max floor, X divided by cell size, and Y is going to be the same. Mass floor, Y divided by cell size. And let's add this function to the list of the functions that we're returning. Let's get this function here. And now, whenever there is a click, instead of getting click coordinates, we'll get cell coordinates from this value. Actually, no, we need to write it slightly differently. Let's put it this way. Get cell coordinates, X and Y. Great, so now the server is receiving the cell coordinates instead of click coordinates. Since there is literally no logic on the server yet, we don't need to change anything here. We just need to send the same turn to every other connected client. However, on the client side, when we are receiving that new turn, instead of using fill rect function, we need to use the replacement function fill cell that accepts the coordinates of the cell to be filled. Now let's see how that all will work together. Let's refresh the page. Let me get rid of this fill cell invocation so we don't have this cell pre-filled. Refresh the page, and as you see, when we're clicking, let me choose the different color. You see, those colors are still not the best. Some of them are just too close to white to be comfortable to watch. But right now, the cells are perfectly aligned to the grid. And if we go and refresh the other boards, right, you'll see that we are all now sharing the same grid and the clicks are perfectly aligned to that grid. So based on that, we will be able to implement the game mechanics. But before we do that, let's go and create another commit, because this is another important milestone. Git commit, and I'll call it just grid. So now you'll be able to check this code as well. And don't forget to check the links in the description for this video. And let's restart the server. Now we are ready to start implementing the game mechanics. So how exactly are we going to implement game mechanics and win conditions? The first step is to make server aware of our game world, because right now server does nothing. It receives a turn from one player and it sends this turn to every other connected player. It doesn't have any logic or decision-making capabilities. Let's fix that. And the first thing to do is to store the state of the game world on the server. And then once we have the game state saved on the server, we will be able to analyze it and to tell that the win conditions are met or not yet met, etc. Modeling this specific game world is very simple. It is just a two-dimensional array with the colors as values. Depending on the game that you're building, it may be significantly harder, but for this game, it is quite simple task. And I don't want to add the two-dimensional array and handling of the game world in the server.js file. Rather, I will create a separate file. Luckily, in Node.js, we have the normal full support for modules, so we don't have to think about that. And I'll create another module called create board. And that will give me a bunch of useful functions for manipulating the game board. I'll create a function called create board, and that function will accept the number as the board size. And I'm assuming a two-dimensional array as the board with the equal sizes of dimensions. Next, I'll create a board. That will be my array. And I'm making it let, not const, because I will be resetting it and setting it to the new value. And I will create a new function to clear that board. Because in JavaScript, it is surprisingly difficult to initialize an empty array filled with nulls, and especially an empty two-dimensional array. So you'll see in a second why is that exactly. So in order to initialize an empty two-dimensional array filled with some values like nulls, we need to start from creating a single and one-dimensional array, And we can do that with just array and passing the size as the value. Then we need to call a function called fill. Otherwise, the next function that I'm going to call, which is map, will not work. So that will fill the array with the values of undefined. And then for each cell in our one-dimensional array, we will create another one-dimensional array of the given size, but this time filled with nulls. This is the shortest way to initialize an empty two-dimensional array filled with nulls that I have found in JavaScript. This is not the most convenient or not the most intuitive notation, but I'm pretty sure you will figure out what's going on here in this line. So we have a clear function, and we also need a function, let's say getBoard. So instead of just exposing the board, I will expose a separate function that will return the board. It's kind of cleaner. And I'll create another function that's called makeTurn. This function will be easy. We'll accept the coordinates of the cell and the color that I want to store in that cell. And storing the color is also just a one-liner, like this. If you're thinking, why did I swap the coordinates? Why I'm putting y first and then x? Just try to print this array, and if you print it, you will see the picture that is exactly the same as on the screen. If you put xy, like you would expect, then the picture will be reverted. So it's just more convenient for debugging. But of course, you can model your arrays both ways. All right, so now we have the set of basic functions. Let's return that. Clear, getBoard, makeTurn. That's right. And since we're in Node.js world, module exports equals createBoard. So now we have created a module for storing the game mechanics, right? So everything outside of this module doesn't know details about how exactly the mechanics is implemented. So let's import that module. createBoard is coming from this file. And now we can start using this function. These functions, there are many of them. Clear get board, and make turn are all coming from create board of size 20. So I'm creating a global board because all the players are connecting to the same level. If your game will have some sort of sharding or leveling system where players are joining different levels, obviously you will have a separate copy of the game world per level that players are sharing. But right now we're working with the global board, so it's just one board for everyone. And now we have these functions and we can start using them. So for example, now the server, instead of just sending the turn over to every other connected player, it can register that turn first. So make turn X, Y color. That's easy. And then instead of just sending this meaningless message, you are connected, we have already established that we are able to connect to the server. Instead, let's create another type of the event that we will be sending from the server to the client. And that type of the event will be board. And I'll be sending the current state of the board. So this way, whenever the new client is connected, the client will immediately get the current status of the level and the client will be able to render that status. All right, now let's go back to the client and make it render that status. So we'll need, I guess, another function here that, let me just collapse that code so it's looking better. I'll create another function here called render board. And rendering board is quite easy. As I said, my board is a two-dimensional array, so its first dimension are rows. So board for each row and Y coordinate. And then in the row, I have cells that are containing colors. So for each color and X coordinate, if that color exists, so if it's not null, I want to fill cell with X, Y color. This is quite easy. I don't want to expose this function directly, instead I want to make it the part of reset. So whenever the new player is connecting, we want to reset the world, and part of that reset is rendering the current state of the level, rendering the current world. So render board, and we need to pass the board. So now reset will also accept board as a parameter. I'll say that by default, the value of board is an empty array. This way, if I call render board without the board, it will still work fine, it will just do nothing. Now I can go back to my main code, and instead of calling reset initially, I can wait on the board message. When I will have the details, when I will have the data, what is the colors in the cells, what are the colors in the cells of the board, I will call reset and pass the board as the parameter there. So reset will be my event listener on the board event. All right, perfect. If everything worked correctly, I wrote quite a bit of code here. I haven't tried it yet, so let's try, right? So I'll refresh the board, I'll click on the cells and nothing happens. And I just realized that I forgot one thing in my server-side code. So initially, we need to start with some kind of a board. So we'll clear it to initiate it with something at all, because by default, it will have undefined value and it will not work. So now let's go back, let's refresh the page. And hopefully now when I'm clicking, yes, I see the cells appearing. But what's more important, let me try to refresh this page, and if these cells are in place after I refresh the page, that means that every connected client will get the state of the world, right? I'm refreshing it, and luckily the cells are there. Let's try it with a couple more clients. As you see, every client is getting the initial state of the world. Now, if I start adding values to the board and I refresh the page, the refresh works. So we're now sharing the board, and what is more important, server is fully aware about each color of every cell on the board, right? And then server will be able to tell when the game is over. And the game will be over, let me remind you, when we have 5 in a row condition, right? So once this 5th cell is rendered, is painted with the same color, I should receive a notification that this round is over, the new round starts, and the board should be cleared. And that will be our next task. But before that, as usual, let's save the progress. Let's do git status and git commit everything with a comment server board Perfect. Now the code is committed, and one of the reasons to do that is because my recording broke already once, so I had to repeat this section, and I really don't feel like losing any more work. So let's return to the code and think how to implement the win conditions. Checking win conditions in the board games may sometimes be tricky, so stay with me. I'll try my best to explain how this works for this game for 5 in a row, right? So first of all, we need to figure out if the board contains the line of 5 cells filled with the same color, and this can be horizontal, vertical line, or diagonal line, each direction. So all these things will work. And if you try to solve it in a general manner, just to take the two-dimensional array and try to figure out if one of these conditions are meeting, it's kind of a difficult task, right? But it is much easier if you know one thing. If you're putting the cell, then the win condition is only possible if this cell is the part of the line of 5, because otherwise, if the win condition is already elsewhere, then the game should not have proceeded to this turn. The game should have ended before that. So basically, at any given point in time, we know that if this cell is not a part of a win condition, then there is no win condition, right? So this is exactly how we will be checking the win condition. We'll be checking the latest turn, and if this turn is making the line of 5. Now, how to make the line of 5? Now, this one is significantly easier. You need to calculate the number of the cells of the same color to the right of the given cell and then to the left of the given cell. If you sum it up together and the result is more than 5, then you have a win condition. The same goes for up and down, the same goes for left and right, and the same goes to the other diagonal, right? So you need to check overall 1, 2, 3, 4 directions to check the win conditions of that game. So you start from the cell and then you choose a direction, and let's say my direction will be right, and you are going through this direction, incrementing the counter by 1 each time when the cell has exactly the same color as the original cell, right? And once you reach the situation when the next cell is not the same color, or you're reaching the edge of the board, that's it. You have counted all the cells in this direction. And then you do the same for the opposite direction. Then you sum it up, and if you receive the value that is larger than 5, let's repeat it, then this is the win condition. So how to implement that in code, right? So the code is a little bit tricky, but if you read it line by line, it is quite clear what will it be doing. First of all, I'll need a helper function that is called inbounds. And that will be checking if the given value xy is still in the board, or I'm getting outside of the board. I don't want to check something outside of the board. So I'll start the check with y, because that's how my array works. It starts with y and then goes x. So if y is more or equals than 0 and y is less than board length, then the y is in the range of the board. This is a valid y. Now we also need to check x. So if x more or equals than 0 and x is less than board y length, then it is a valid turn. And my IDE is suggesting that I'm working with JSX. No, I'm not working with JSX, dismiss. It's just that I'm having a syntax error here. All right, so now this expression is correct. Now this function will help me to check if the given turn is still in the board or it's falling outside of the board bounds. All right, the next function that I will need to create is get the number of matches of exactly the same color as the cell in question. So I'll call it num matches. Now this function will accept xy, the starting cell, then it will accept dx and dy, which will be the directions of the movement, and the values will be -1, 0, or 1, and that will show in which direction we are moving: right, left, top, bottom, or diagonal. So I will create a counter, and that will show how many steps in the given direction do I need to take to check the next cell, and I'll start from 1 step. Obviously, I don't want to check the 0 steps because that will be the cell itself. So let's say I'm here right now in this cell, right? So now I need to check if the next cell is still in the bounds, in the board. So in bounds, x plus I by dx, y plus I by dy, right? And also, if the color of this new cell is the same as the color of the original cell, so we'll express it like board y plus I by d y, x plus I by dx is exactly the same as board yx. That means that I have found the new cell that is exactly the same color as the old one, so I'll just increase the counter by 1. Now, once I have counted all such cells, and this loop will end at some point, either I will hit the end of the board or I will hit the cell that is not the same color as my own cell. I will return the number of matches minus the original cell itself. Right? So let's say I have this scenario, right? 1, 2, 3. And I have ended in this cell. So this rightmost cell is the last one. Let me increase the size of this board a little bit. So I will start checking the different directions. And the direction for me will be dx will be -1. So each step I will be moving -1 through the x, and dy gonna be 0. Each step I will stay on the same y coordinate in the board. So I will check this cell, then I will check the second cell, I will increase the counter by 1, then I will check one more cell and increase the counter by 1 again, that will be 3, and then finally I will try to check this cell, but it will turn out that the color of the cell is not the same as the previous color, so I will stop and then I will return the value of 2, because I have found in this direction, right, I have found 2 cells exactly the same color as the cell of the turn, right? And this is pretty much the core of our endgame detection mechanics. Now all you have to do is implement function is winning turn. And this function will receive just x and y. So now I need to build this function to implement 8 directions. 1, 2, 3, 4, 5, 6, 7, and 8. And instead of writing that down with delta x and delta y, I can do that in the loop for each possible direction, and the possible directions are dx starting from -1, dx less than 2, dx plus plus, same goes for dy. I need to check if both values appear to be 0, I don't have to do anything because I will not move anywhere and I will end up in the infinite loop. And in all other cases, I need to count how many cells do I have in the row with this given turn. So number of matches of x, y in the direction, dx, dy, plus the number of matches in the opposite direction, so minus dx minus dy. And then plus 1 for the cell itself. And if it turns out that the count is more or equals to 5, then I will return true, saying that this was the winning turn. Otherwise, somewhere at the end, I will return false. Now let's quickly test this new function. I will add this check to my function that is called makeTurn, and I will just return is winning turn xy. So now my server can check if this turn was a winning turn. All right, player 1 equals makeTurn xy color. Now, if everything works, we will know that this player just won. So it's a good idea to tell him congratulations. So if player 1, we'll do sock. We just want to tell it to one player. Emit message, you won. And then we want to do io.emit, and we want to tell everyone else that there is a new round. Everyone actually including this player himself. So I'll say message and new round. And finally, we want to tell all the players that it's time to reset the board. io emit board. And since the board is not passed together with this message, my client-side code will know that the board is empty. So now let's see if that works in practice. So I'll start with just one player, and let's start adding the values here. And finally, just when I clicked the 5th cell, I have received the notification you won, new round, and also reset of the board. Let's see how that works with a couple more connected clients, and we'll see if that will really work. Or in fact, I have forgotten to to clear the board on the server side as well. So let me do that really quickly. Let's go to the server and call clear here, and this function will clean the board. And let's reset it again. All right, so all starting from the blank. Somebody's winning, new round, and this player got U1. All right, so if we try it with 2 players or 3 players, once one of them is winning, we got the new round notification. All right, perfect. So we have win conditions now in place. The server is tracking what is happening on the game world. It has taken into account the state of the level, and now the last bit that is left for us to do is to add a little bit of polishing on top of our project. Now let's implement the last bit and we can count this little project complete. It's already more than an hour, so I think it is a good time to start wrapping it up. But before we do that, the last bit that I want to add to this game is to prevent players from just clicking very quickly and submitting tons of turns in a hope to win. I want the turns to have cooldowns, pretty much like spells in online games, so you cannot submit more than 1 turn per 2 seconds. How to do that? And this part should be quite easy for everyone who worked with Node.js and JavaScript at least a little bit. So I'll create a new function here, a new module that will be called create cooldown. And again, we can implement the whole cooldown tracking inside of the main server file, but it will be just nicer to have it in a separate module, in a separate file, and encapsulate the logic of calculating that cooldown inside of the function. So let's add a function, create cooldown, and that function will receive the timer, the timeout. Let's call it a delay, even better word. We'll have to count the last update time, and at the beginning it will be 0. So immediately after you have joined, you will be able to make a turn. So now let's return a function from this create cooldown, and that function will do 2 things. Firstly, it will check if the cooldown is already cooled down. So if enough time has passed, and to do that we'll take date now, so the current time minus last update time, and check it to the delay. So if it is bigger than the delay, that means that the turn is allowed. So here we will update the last updated time to the current time, date.now, and then return true. So this function is kind of doing 2 things at the same time. Otherwise, return false. It checks if the turn is possible, and if it is possible, it resets the timer to the new value. And of course, let's not forget to export it. Module exports equals create cooldown. Now I can start using this new module in my server. Create cooldown is required from this file, create cooldown.js. Now the cooldown time is individual per connection, per player. So we are creating the cooldown inside of the connection event listener together with the color. It is something that is individual for the player. So cooldown equals create cooldown. So create cooldown, not the board. And let's give it 2 seconds delay. 2000 milliseconds. And now we will only allow the turn to happen if the cooldown is allowing it. So if cooldown, so if the turn is allowed, we're doing everything that we wanted to do with the turn. Otherwise, we will not do anything at all. We will not count this turn and we will not send it back. So this way the player will know that nothing has happened. So let's test if this new function works. So let's try to add a cell. Let me refresh it a couple of times so that I have a better color. No, I'm absolutely unlucky with the color. So now this one is quite good. So I'm clicking and then I'm clicking, but only after 2 seconds my next turn is allowed. You can increase or decrease it, or you can make some more interesting logic, like the more cells of your color you have currently in the game board, the bigger is your cooldown. That way players will need to plan ahead and think how many cells do they want to conquer. And that will pretty much be it. We have created our very basic multiplayer game that has the game rules, a real-time game rules that allows many players to connect to the same world and share the level structure together, playing this simple game. So congratulations, you have made it to the end of the workshop, and I really hope that you are inspired and you learned something new about the multiplayer game development. Now, before we close this project, there is one more thing that is important to take into the account, especially if you plan to take this code and take it to your own server and host it and show it to your friends. When it comes to chat, in this project I have not implemented any security restrictions. So in theory, somebody can start writing an HTML, and that HTML will be injected into the pages of other people, so something like this. And as you probably know, this is not the best idea that you can have. This way it is possible to inject an arbitrary code in some other people's browsers, and this is a security vulnerability. So if you want to continue developing this project on your own, just pay attention to security, make sure that you're sanitizing everything that comes from the chat. But other than that, this project is done. So thank you very much for watching. I hope you enjoyed this video, and please, before you close this video, please leave a comment. Did you like this workshop, or tutorials worked better for you? Let me know what you think, and let me know what other subject would you like to have covered, or what little projects would you want to build together on my channel. Thank you very much for watching, and see you in the next videos. Bye!